G'day and welcome to the first video on the binomial distribution. This video is a part of the discrete random variable series, but it's just a particular type of discrete random variable, and so it's exercise 8.3 in your textbook if you're following along. Now I'll just give you a situation and I'll sort of explore the binomial distribution almost by building things up. Imagine flipping a coin 2 times and observing the number of tails obtained. If x is the number of outcomes defined by the number of tails, and the distribution of x is the following. So x is 0 tails, 1 tail, or 2 tails after flipping it 2 times, and we get a quarter of the time you'll get 0 tails, a half the time you get 1 tail, and a quarter of the time you'll get 2 tails. And we can work out. You can use the tree diagram to kind of work that all out, to prove all that. But I'll just assume that you believe me on that. Now notice how the first outcome, x equals 0, and the last outcome, x equals 2, only have one branch of the tree diagram, like that one and that one. But when x is equal to 1, so 1 tail, it has 2. It's got this one here and got this one here. So I guess it follows this pattern 1, 2, 1. If we manage to flip the coin 3 times and still obtain the outcomes of tails, we'd have 0 tail, 1 tail, 2 tails, or now 3 tails. If we flipped it 3 times, the number of branches that x equals to 0 has, so 0 tails, would still be 1 because all heads. There's only one way that can happen. And I guess x equals to 3, as in 3 tails, that will still be 1. But then there'll be 3 options where x is 1, so where there's only 1 tail, and 3 options where there are 2 tails. So I guess it follows this pattern 1, 3, 3, 1. This number pattern should remind us of Pascal's triangle and basic expansions of brackets. 1, 2, 1, 1, 3, 3, 1, and then was it 1, 4, 6, 4, 1. If we jump a few steps, if we wish to find out, say, the probabilities of a much higher number of flips, say 10, we could possibly use the binomial distribution to find out how many ways that can possibly happen. There's a couple of conditions for using the binomial distribution, and I'll go through those first, and then I'll explore actually how the binomial distribution works. The first condition is that each trial, or in our case flip, is independent of the previous trials. If it's not independent, you can't use the binomial distribution. It relies on independence each time. Okay, so the previous result doesn't affect the next result, and that's true with flipping a coin. The second condition is that the probabilities in each trial, or each flip, are the same. So each time you flip a coin, the probabilities can't change. So it's always 50-50 whether it's going to be a head or a tail. And the third one is that it's based on a success and failure outcomes. Okay, so you've either got a success or a failure. So even if rolling a dice, there's 6 options in rolling a dice, but what we would say is, say rolling a number under, rolling an even number is a success, and rolling a non-even number, so an odd number, that would be a failure. Okay, so you have to have either a success or failure. If you don't have the only 2 options, then you can't use the binomial distribution. But if those 3 key things are present, then we can use the binomial distribution to crunch out a whole bunch of really complicated things for us. Okay, so we can use the following formula to find out the probability of any one outcome. So for example, if I said the probability of flipping the coin 10 times, what's the probability of finding, say, 3 heads? I could do that fairly quickly using the binomial distribution and the formula, which I'll show you right now. The binomial distribution looks a little something like this. So the probability that x equals a particular outcome, I could say that x equals 3, as I said before, and I know that the total number, and I'll go through all of these variables, n, p, q, and x. So n is the number of trials. So in my case it's 10. I might even do this over here. 10 number of trials. C, and then x is the number of the desired outcome. So in my case it's x equals 3. And then I do the probability of success, which was a half, all to the power of x. In this case it's 3. And the probability of failure, which is also a half, and n minus x, which ends up being 10 minus 3, which is 7. If I did that on my calculator there, or if I did that by hand, I would actually find out the probability of obtaining, flipping the coin 10 times and obtaining 3 tails. Exactly 3 tails. No more than 3 tails, no less than 3 tails. So that's the formula there. I might rub this bit out just so we can just leave the formula up. I hope. almost there. A little bit more. Okay. So that's the formula that you can use to find out any one particular outcome. And this formula down here is exactly the same. It just recognizes that Q, the probability of failure, is actually just 1 minus P. So it can be P times 1 minus P, but it doesn't really matter either way that you use it. Okay. So what I'm going to do is I'll leave the video there, and in the next video I'm going to explore a couple of different questions that like basically applications of these formulas, just so you get the idea of what's going on. So thanks for watching.